Hello, all. Welcome to today's session, a partnership between the Qt Company and BlackBerry QNX. During today's session, you will learn how tools from both of these brands can help address medical and industrial challenges. You'll hear from experts from both BlackBerry QNX and the Qt Company. Starting off, you'll hear from Pat Shelly, Manager of Solutions Architecture at the Qt Company. Then we'll hear from Shawn Dorsey, a technical artist at the Qt Company, and Elton Lum, Director of Field Application Engineering at BlackBerry QNX. So without further ado, I will pass it all along to Pat, who will give you a little bit more information about what you can expect from this session.
I'm with the Qt Company, so we do, primarily HMI type applications. So we're drawing stuff on screens, and we have to make sure that that content, or at least some subset of that content, is completely accurate when we're working in a medical or industrial environment. So that's kind of our piece of it. And then underlying that, our very strong partner, BlackBerry QNX. They have platform level software that addresses functional safety as well. And this combined solution is really particularly great for these two markets and a few others. We've been working with QNX for a long time, and literally decades. So it's a very mature solution. It's been around for a long time, and it's evolving, continuing to evolve to address standards as they change going forward. So today we're going to look at some examples, really primarily an industrial example. And to go through that example, I'm going to pass it over to Shawn Dorsey.
Great. Thank you, Pat. All right, hi, everyone. So today we're going to go into a demonstration of a smart warehouse. And what I have set up is an example of how we can utilize Qt's cross-platform capabilities. Now you'll see here, I have a multi-screen connected interface consisting of a desktop, an MCU or a microcontroller, and a mobile device or a tablet. Now I'll be diving into the details of how I built this a little later on. But to set the stage for this example, I'm going to jump into a virtual warehouse scene that I built in Autodesk's Red or VRED application, which coincidentally is also built with Qt. Now, typically in VRED, you would use an Oculus headset, something like this, for a more immersive experience. But we're going to keep things pretty simple today. Now, through Qt's WebAssembly, I can stream my entire interface into VRED through the media player plugin within VRED. So here, I'm just going to start streaming my Qt Design Studio user interface. Now you'll notice in front of me, what I have here looks like a desktop workstation and a mobile device or a tablet located over here. And then on my individual robots that will be moving here shortly, I have what is a perfect use case for an MCU. Now, imagine, if you will, I have a warehouse filled with robots that can deliver racks with products to be packaged and shipped. Now, this station over here, the desktop application, would tell me which robot is delivering the rack, which shelf and which box that item will be located, and the approximate time, overall time that robot is working on the job. The tablet over here, my mobile tablet, which could be controlled by another individual, can see a bird's eye view of every robot on the floor and make changes, all interconnected through Wi-Fi. Now let's start this entire scenario here. Now we see down at the bottom here that this robot is looking a bit slow, so we should investigate. So I'm going to go over here to my controller, and I'm going to activate it, and it appears that this robot has a predicted failure, and the failure is located with the hydraulic system. Now I can manually and safely override this robot and send it to a different location. Now there's a new robot here that's activated and will take the place of the robot that had the predicted failure, and eliminate any potential harm on the warehouse floor, as that robot could fail while it is in progress. And this new robot is automatically assigned and has updated the packaging monitoring system with the new robot's details. All right, now I'm going to flip over to a different workstation here and talk about how this entire assembly was done. Let's load this. Okay. Now using Qt Design Studio, which is our design tools application, what I can do, or what I have built here is this application. So Figma to Design Studio. Now with Figma, I created the entire layout and components, and I can bridge all of that information directly into Design Studio and maintain all of the connection, maintain all of the pixels in a perfect XY coordinate system, exactly how they were intended. And in Design Studio, I can add in things like the interactions, the animations, and the controls. Now, an output of that completed project could be streaming it to this VR application in Red, or directly preview it on my desktop. Let's take a look and see what that actually looks like. All right. So this entire layout was brought in directly from Figma, and I bridged all the components in so they match my original design. This is the Figma application through the bridge tool into Design Studio. And I'm gonna go ahead and run it as a desktop application and walk through this scenario again, give you a little clearer picture of what was happening in the virtual simulation. So I'm gonna activate my predicted failure. And I notice here that it does have hydraulics that it predicted. I'm gonna send the application to the dock. And now in the other two connected devices, you see my GPS on my robot has been rerouted, as well as the packaging or the delivery person's information, along with the shelf and the box number. Now, what I want to close with here is just how easy it is to add in the QSR, the Qt Safe Renderer elements to my design. What I have highlighted here, and what these are marked as safe text, but they really won't look anything different visually. And I can just drag and drop those right into my design, and that can be a safe text, a safe picture, or a saved image. And what happens downstream in our Qt Creator or IDE is the tooling around the safe renderer can remove or hide the safe renderer items from the Qt Quick application and generate this MISRA C++ renderer as a separate app. And to go into more details about QSR, I'm going to pass it over to Pat Shelly.
All right, thanks, Shawn. Okay, so I'm going to take a few minutes and run through what the Qt Safe Renderer is. Let me see if I can hide this. Sorry about that. Qt Safe Renderer is an add-on component to the traditional Qt framework. So in addition to normal rendering and serial interfaces and file system interface, all the other aspects of Qt. Now there's this piece called Qt Safe Renderer. It's been around for quite some time, actually, and it's used in a number of production systems. The purpose of the Qt Safe Renderer, really at a high level, is really to create a safe user environment for medical, industrial, and other industry segments. And so it does so by, like in the medical case, the emergency room, the operating room, or intensive care unit. If there's a device system failure, we want the doctors and nurses to continue to focus on the patient and not about rebooting a machine or something like that. So we're trying to keep the environment safe, and that's in the industrial case, whether it's a manufacturing plant or a warehouse, there's automated equipment running around or moving around in that environment. And if something goes wrong with those systems, you have to notify the people in the vicinity, the end users, and anyone in the area. You have to provide notification of the failure and take some corrective action. And if those notifications aren't actually seen, if they're not being presented properly, that's a huge problem. And you have to bring the system to what's called a safe state. So that's exactly what the Qt Safe Renderer does with respect to the HMI. So if there is a failure, something's being displayed incorrectly, and the messaging that's intended to go to the user or the people in the area, if that messaging isn't getting out, you have to take corrective action, which can be putting the system into a safe state. That safe state is always, it's defined by the device manufacturer, but it could be, for instance, if a heart rate on a patient monitoring system says 120, but it's really 60, right? It's presenting incorrect information. In that case, it's better to not present any information than to present something that's incorrect and may drive the attending doctors and nurses down a wrong path with regard to taking corrective action on the patient himself. So it's really intended to prevent the display of incorrect information, especially where that information has been deemed through a hazard and risk analysis process. It's been deemed to be safety critical. So we single out the safety critical elements, separate those from the rest of the UI. You don't see that, as Shawn indicated, you don't see that in the design tool. Qt Design Studio, you'll see everything where it's supposed to be. But when the system is actually built, the UIs are created in a couple of different domains. And this is in line with this notion of mixed criticality systems. So with mixed criticality systems, you don't have to certify the entire system. But for those aspects, those elements of the user interface that have been deemed to be safety critical through a hazard and risk analysis, those parts can be singled out, separated out in the runtime environment and rendered separately. And that separate process is kind of minimal, and it is certified, where the richer, the broader UI around those components can be rendered as it normally is in any device. So you're kind of separating the safety critical from the non-safety critical components and rendering, creating really two different domains. And that's a measure to allow a richer user interface. So you might include 3D elements and have a really rich UI like you have in a cell phone app, even on a patient monitoring system. You can have those rich UI components which aren't really certifiable, or it would be super expensive to do so. So you can have those, but still have your safety critical elements rendering from a safety critical subsystem. So that's what Qt Safe Renderer does, and it allows you to draw, as Shawn indicated, put telltales, images up on the screen, or text, write text. And if that text is deemed to be safety critical, the Qt Safe renderer will make sure it's presented correctly. And if it's not, because of some fault in the system, it will take a corrective action to recover from that and notify the end users that there's a problem with the system. So you don't need Qt Safe renderer to get your system certified. But if you do use something like the Qt Safe renderer, it'll save you a ton of time and money. When you're going for certification of a device, there's a lot of different aspects to the device. And each of those aspects have to be certified. One of the aspects is safety critical elements in the HMI, in the display. So by using an off-the-shelf pre-certified product like Qt Safe renderer, we develop to the same safety standards that the device has to conform to. And we're pre-certified for use in those type of systems. And pre-certified as a component of your system means that we will provide all the necessary certification artifacts that you need for that HMI component of your system. And you can use those artifacts directly in the safety case that you have to create and provide to the certification body when you undergo certification. So there's a whole book you create, and each chapter of the book is a different aspect of the system. And one of those aspects is the safety critical UI components. And you can literally take the artifacts that we provide with Qt Safe renderer and slide them in as that chapter of the book. You don't have to do anything further. It's just kind of pass through. Where if you wrote it yourself, you would have to run tests, collect test results. There's design documentation. There's a lot of things, all those artifacts you would have to collect, assemble yourself, and it's quite time consuming. So that's really why the Qt Safe renderer exists. It's to create the safe operating environment when needed, and it's really to expedite the deployment of your system into the market, make it quicker, and save you money in the process. Now, how the QSR works is it is rendering those safety critical elements from a separate domain. And examples of these, as we said, could be images, it could be text. And we're separating the safety critical elements from the rest of the system. Now, the QSR will take a heartbeat signal from the main UI. So if it detects the main UI, the unsafe, non-safe UI has locked up or has an issue, it has the ability to take corrective action there and maybe reset it or shut it down. So it is monitoring the other piece, but its main function is to make sure those safety elements are rendered under all circumstances. And if they're not able to be rendered, that the system goes into some corrective state. And so you may reset the main UI because it locked up. That's fine, but those safe elements will continue to be rendered while the main HMI is restarted and rebooted. And so with this mixed criticality, this separation, Qt can be used in the full Qt stack can be used in systems requiring certification, but you're separating out those safety critical elements into a separate domain and they're rendered separately. So the overall system is certifiable. And that, of course, has dependencies on the underlying platform software, and Elton will get into that in a few minutes here. So the Qt Safe renderer comes with a number of components, and it is seamlessly integrated with the traditional Qt toolchain. So we have the Qt Design Studio, Shawn covered that, Qt Creator, and all the build toolchain underneath that. QSR is seamlessly integrated with our traditional build system. And in a way that's actually really cool. If you're doing testing of an HMI, as Shawn was just doing, you're not building it for that certified device. for the final target environment, but rather you just want to see how things look, how they behave under test. And the build tool chain recognizes that. So it allows you to build the safe and the non-safe components together so you can see what the system looks like, how it behaves when you're prototyping or testing in say a desktop environment, as Shawn was. You can see what the final system looks like. You don't have two different design and development environments. It's all pulled together, but the build tool chain separates those. So it pulls the safe elements out from the main UI. And when you're building for the final target environment, it will build those separately so they can be hosted in separate domains. Now, the latest version of QSR 2.0, also includes includes a new component called the safety monitor, QSR safety monitor. And this has opened up the additional architectural options. So I've been saying two domains, a safe domain and a kind of an unsafe domain. There's new ways that we can address that separation with the latest release of QSR, and I'll talk about that in a second. So as I said, the QSR, the Qt Safe Renderer, is pre-certified for certain industries. We provide the certification paperwork. We provide all the artifacts that back up this certification. So we get our certification from TÜV Nord. And to get that certification, we have our processes audited. We have to create all the artifacts around the safe renderer. So it is pre-certified in that sense. Why didn't we certify just the whole Qt framework? It's just too big. We have a really rich set of capabilities that have evolved over the last 27 years or so. It's quite a large system though, and there is a cost associated with the certification. So just as you find with like Linux systems, there's people that think they're going to certify Linux, but the code base is just entirely too large. And that's where products like QNX come into play. So the main Qt framework is just too large for certification. So we took an approach, this mixed criticality approach that a lot of people take. Where you separate out the safety critical stuff, you create it in a certain way. So we have a small code size, so it's kind of easy and cheap, cost effective to certify. We code to MISRA C++ guidelines. Now MISRA is something from the motor industry, from way back in the 90s, but this is a standard that's been adopted in many other industries. To provide guidelines on how to use C++ language in programming software for safety critical systems. So we do follow that guideline. We also pre-allocate everything. So all data is allocated at startup, and we're not doing dynamic memory allocation. Now, as far as the runtime environment, with the separation, we could have QNX OS for safety, for instance, a certified solution. We can run that rich UI, the main UI, and the full Qt framework on that. But then in a kind of separated out, we run the Qt Safe Renderer with the safe UI components. So this would just be the safe text, kind of telltales, images, whatever that messaging is that's been deemed through a HARA, hazard and risk analysis, been deemed to have safety requirements tied to it. It's rendered in a separate domain with a separate rendering engine. And so you can bring uncertified code into the system, but anything that touches the certified code, that whole flow through, that whole chain of that flow has to all be certified components down to the hardware. So with QSR, that safety critical graphics is generally rendered to a separate plane in the graphics environment. So in the background here, you see the rich UI that's rendered by the uncertified domain and using the full Qt framework. So there you have access to 3D elements and everything else, all the great things you can do with Qt. But then separated out and drawing to a separate plane is just the safety critical components. And those are rendered from a safe domain. They're separated. The code is separated in how it executes in the runtime environment. It's rendering to a separate plane in the graphics framework. So that's how we bring that separation out to the displays. Now, the Qt Safe Renderer really comes with 4 components. There's the designer tooling, and we saw an example of that with Qt Design Studio. You can drag and drop these safety elements into your design. That results in QML code being created, which is our declarative language for defining UIs. That code is created automatically through the Design Studio interface. And those components that are safe components, the Qt Safe Renderer components, they have special component names that kind of single them out, and they're handled separately as a result in the build process. We provide the build tools, and that automates the partitioning. So the separation of the safety critical from the rest of the code. That's all handled by the build tools, which we provide. We provide the runtime component, the actual pre-certified rendering component, and all the certification artifacts to help you with building that safety case that you need to get certification. We saw this on Shawn's desktop, but the designer tooling, primarily Qt Design Studio, there's the safe elements available in a library if you choose to include that into your design. So it's super easy to add functional safety to any existing UI. We have a browser that brings in some icons, so some very international standard icons used for safety and other cases, but a standard called ISO 7000. We have a browser that allows you to bring those standard icons into your design. How the build tools work. So if you're building for the desktop, doing rapid prototyping or testing on a desktop, the tools know that. They know it's not building for the target functional safety certified environment, but rather just for testing. So it will kind of lump everything together so you can see what you have all in that one design tool, or when you're prototyping, you see it all on the screen, all combined. But when you build for the target, that's when the build tools actually separate out the safe from the non-safe UI elements and create the runtime environment separately as such. So you don't have to change anything between your prototyping and your testing environment to going to the actual hardware. Now, I mentioned the safety monitor that's been added to QSR 2.0, the 2.0 release. And what that allows us to do is you have a main UI. So this would be a rich UI. It could have 3D elements. It could have a lot of different stuff in it, running on QNX OS for safety here. When you start bringing those QSR elements into your design, what happens is you're actually creating a separate kind of process, a separate domain where the safety content is rendered, and it's rendered to a separate layer in the graphics environment. So with the QSR Safe Monitor, you have the ability actually to separate out the checking, the part of the system that checks to make sure what you meant to write to this display is actually there. You can separate that out from the thing that actually draws it. And it opens up the door for, I think in some ways, some simplified architectures where you can offload your functional safety content onto, in some cases, a separate chip that's just dedicated for maybe system data interfaces, data buses, and functional safety handling. So it gives you a little more flexibility in how you architect a safety system. So systems that in some cases might require hypervisors, you might be able to eliminate the need for that. And with that, I'm going to pass it over to Elton. He's going to run through a few aspects of how QNX helps with this solution as well.
Thank you, Pat. If you aren't already familiar with QNX, we focus on providing foundational operating system level software that is safety certified, which other software like Qt can build on top of with such products as their safe renderer and HMI technology. The original functional safety standard for such systems, called IEC 61508, was published 2 decades ago. It has since been used as the basis for other functional safety standards, which have been adapted to specific fields. And they are not one size fits all. IEC 61508 is prescriptive and calls for specific techniques, while ISO 26262 for automotive is more goal-based. Other standards like EN 50128 calls for independence and role definition, and IEC 62304 is more about following your own processes. On to the next slide. We at BlackBerry QNX have been helping streamline safety certification for over a decade. Our involvement with functional safety standards started more than 10 years ago, back when we released our first certified product to IEC 61508, the QNX Safe kernel, a certified version of our popular QNX Neutrino microkernel. We've since released several certified versions of our QNX operating system under the brand name QNX OS for safety, with the addition of certification to ISO 262 for automotive and IEC 62304 for medical. And we've always done so to the highest safety integrity levels. We've also enabled customers in nuclear, as well as rail and signaling with such standards as EN 50128. As you can see, we are constantly expanding the certified scope of our safety products, going from the microkernel, C library, C toolchain to the C++ toolchain, and more recently, the math library and ARM SMMU and Intel IOMMU support for bus master caging. Last year, we introduced the first version of our QNX hypervisor for safety, a product that can scale as both a type 1 and type 2 hypervisor and provide virtualization support for popular operating systems such as Linux and Android, with support for a multitude of virtual devices with the popular VirtIO standard. We have also recently introduced add-ons to QNX OS for safety with the certified standard C++ library and the QNX Black Channel Communications technology, a product that supports the Black Channel approach, which we will describe further. One thing that is foundational to the development of safety software is having the right operating system architecture, because there are essential freedom of interference measures that are directly influenced by the type of kernel you have. So there are 2 types of OS architectures in use today, those being the microkernel and monolithic OS architectures that rely on hardware memory protection. Applications and middleware, whether they're implementing safety functions or not, can be separated through spatial separation that is called for by ISO 61508. However, with microkernels, which are more popular with embedded and safety critical systems, what is running at the most privileged level of execution, often referred to as kernel space, is the scheduling, process, and memory managers, while device drivers and system services are running alongside applications, separated from each other and the kernel as well. This reduces the risk and attack surface on the kernel, which is essential to the safety function of the system. It is not so with the monolithic OS architecture, which is more popular with personal computers or enterprise servers. With this particular architecture, device drivers and services can run at privileged execution levels, and this can affect or corrupt the core functionality, putting the safety functions at risk. Now let's elaborate further on the Black Channel approach and what that means. Black Channel can be classified as a method for safe communication. Nowadays, safety and security concepts are often blurred together, and rightfully so, given the nature of connected devices today. However, there is a distinction between secure communication and safe communication. Secure communication is when two entities are communicating and do not want a third party to listen in. This third party can represent a malicious threat, and communication security protects against this. Specifically, secure communication seeks to prevent the interruption of the communication or an unauthorized person reading the communication, or having unauthorized data being sent or authorized data modified by unauthorized persons. On the other hand, the goal of safe communication is to provide measures for data integrity. So this can include detection of random hardware faults like bit flips in memory, or corrupted packets that may occur during the active transmission on a communication bus. In addition, there can be measures for data authenticity to ensure that the message received came from the expected or legitimate source. With safe communication, there is no requirement for data encryption, nor to provide measures to prevent third parties from listening in. So with that, let's dive right into safe communication. With connected devices, the data communicated over any link is subject to a number of vulnerabilities due to the effects of faults in the underlying software and hardware used to transport the data. It is not assumed that the software or hardware comprising the communication system is certified or qualified in accordance with ISO 262 or IEC 61508. In many cases, the task of achieving certification for the underlying network stacks, drivers, and transport hardware, otherwise known as the white channel approach, is prohibitively complex and expensive. Alternatively, the safety bag approach or black channel approach allows for the detection of faults through integrity checking, data loss detection, and other measures to ensure that the data can be safely used without having to certify all of the underlying components like the networking stack, drivers, and transport hardware. For the white channel approach, if we look at the diagram on the left, you will see two applications that are on two separate pieces of hardware that send data back and forth. To establish safe communication for this scenario using the white channel approach, you will have to certify every single aspect of the communication path to the functional safety standard that is required for your system. That includes the communication protocol, services, and underlying hardware. This will clearly reduce the risk of hardware and software fault introduction into your system. However, this approach is extremely costly and time-consuming to be able to certify all these elements to the functional safety standard of your choice. For the black channel approach on the right, the use case is the same, where you have two applications communicating on two separate pieces of hardware. However, the black channel approach recommends a safety layer that sits at the application level, where the sender application sends its data to for essential safety checks prior to transmission. On the receiver side, upon receipt of the data, it sends the data to the safety layer to check and make sure the data hasn't changed. That safety layer has to be safety certified as well as the application. However, given the fact that you have the safety checks on both sides of the sender and receiver, the approach highlights that you don't need to safety certify the components underneath, like the communication stack, COM driver, and hardware. This is clearly cost-effective and less time-consuming when it comes to safety certification. It also allows you to use uncertified communication components in your design. This gives you greater flexibility in terms of what protocol bus you would like to use, whether it's Ethernet, Wi-Fi, CAN, or other industrial protocols specific to your needs. So now, if we were to refer to our highlighted use case that Shawn has outlined today, let's see how we can apply safe communication measures to this scenario. In this case, hardware 1 represents the tablet operated by the remote user, and hardware 2 represents the industrial robot. The prime use of safe communication would be any critical operation, such as an immediate halt to a given robot operation to prevent an imminent disaster of some sort. For example, let's imagine a robot is carrying an uneven, heavy load near warehouse employees, which may risk falling on someone. The remote operator would initiate a halt or stop action from the Qt UI. The halt command would be encapsulated with a safety header, and this would be transmitted to the robot in question. Upon receipt, the receiving Qt application on the robot would receive this data and verify that it is indeed a correct and and authenticated command from the appropriate remote user. When coupled with Qt Safe Renderer, not only would the verified command be received and correctly acted upon, the corresponding UI would be guaranteed to show correct or meaningful status on the screen, such that all users or viewers of the robot can understand the robot's status, and even if there may be a glitch, error, or malfunction in the robot system. One thing I would like to highlight is that our black channel technology is applicable to other operating systems and not just QNX. This is to address use cases like this one, where the tablet can be Linux-based and the robot is running QNX. We also support safe RTOS for other critical embedded applications. So what specifically are these safety checks that the black channel safety layer looks for? The safety layer has to check the data to ensure the faults in the table here are not detected. This list is defined in IEC 61508 and ISO 26262 standards. This safety layer has to check for incorrect addressing, corruption, repetition, incorrect sequencing, data loss, data insertion, data masquerading, asymmetric information to multiple receivers, and reception only by a subset of receivers, and lastly, delay of information. As you can see, the list is quite comprehensive and covers a lot, if not all, of the hardware and software faults that could typically arise in any system that are not malicious from a third-party threat. I hope this gives you a good understanding of what safe communication is all about and how, in conjunction with foundational safety software, it can give you a high level of confidence in building safe and connected devices. Back to you, Pat.
All right, thanks, Elton. So I guess in closing, hopefully you found this informative. It was a good, kind of high-level overview of the Qt Safe Renderer and Black Channel from QNX. That combined solution really is it's an awesome, it's a very mature and very capable solution for medical, industrial, and other market segments where you run into functional safety requirements. Using pre-certified components, as we're talking about, along with that mixed criticality notion where not everything in the system has to be completely certified, will definitely save time and money in developing safety critical applications. And of course, we'd love to talk to you if you run into these type of requirements or have interest in learning more about the products that we talked about here today. Would very much like to have that discussion with you. Reach out. We will. We'd look forward to that discussion. And with that, I'll turn it back to Jillian. I think we have some questions teed up in the Q&A. So thanks, everyone.
Jillian, you are muted.
Of course, thank you. So yes, thank you, Pat. We do have a few questions. If you do have questions, please add them in the Q&A. You'll be able to, if you hover over the bottom of the screen, you can see the Q&A box, and you can pop that out and add your questions there. But we do have several that have come in. So the first one is Black Channel for both safety and security? So that would be for you, Elton.
So Black Channel primarily is for safe communication. To add security, that would be in addition to what Black Channel offers. So, whether it's encryption or other security methods, those are things that would be used in conjunction with Black Channel.
Okay, all right, wonderful. And then one for you, I believe, Shawn. Someone's asking, how does the Figma bridge work? Does it just export a batch of images to a folder and the developer reassembles it in a code? So any additional details you could provide there?
Sure. Yeah, that is the typical scenario. But what Design Studio is intended to do in the Figma bridge, when you export your entire Figma UI, what you're doing is you're exporting an extension called the Qt bridge, and that is going to keep everything mapped. So PNGs and a metadata file are mapped into this Qt bridge file. So there's no longer this reassembling of PNG assets and up to the developer. Now, everything from the bridge is written in this metadata file, which captures all the placement of every asset in the entire interface, components, entire layouts, all of it. That way, when you bring it into Design Studio, that metadata file rewrites in QML in a perfect pixel to pixel relationship. So there is no redoing of any work.
Wonderful. And then a couple more for you, Elton. So someone is asking, is the QNX Black Channel communication run on Linux OS?
Yes, so Black Channel, the product itself from us, is available in source code when we deliver it to you. And it's a standalone library that you effectively can compile for various operating systems, so Linux being one of them.
Okay, wonderful. And then I'm just going to keep it over with you, Ellen. So let's see, if I'm not using one of the supported operating systems, can I still use Black Channel? You kind of touched upon that a little bit, but do you want to answer that a little bit more explicitly?
Sure, that's a good question. As long, in terms of the certification of Black Channel, as long as the prerequisite of a safety qualified tool chain is involved, and the OS in question is certified or certifiable, a customer can use our safety artifacts that we provide and test cases to help them certify Black Channel on the particular OS of choice.
Wonderful. And then let's see, does the certification apply to all supported operating systems?
So yeah, that's same answer as
different way of wording it.
Yeah.
Yes. Okay. And let's see, we sort of covered this. What is the difference between QNX Neutrino and QNX OS for safety?
So from a technological standpoint, they are exactly the same from a user standpoint. What is different is that with the OS for safety, it has gone through all the rigorous testing, all the safety artifacts and test cases have been generated to show that that particular version of the OS is safety certified and can be used in safety critical applications that require certification.
Okay, perfect. Then I am going to bring it back over to the Qt side. And this is another one for Shawn. On both the Figma UI layout and the finished Qt Designer application, how long does something take to create?
Sure, yeah. It really depends on the complexity and the overall design of the project. Many screens can take a lot longer than a few. But I'll say for this example, what we showed today, the Figma part of it, anywhere from, I think that was 1 to 2 weeks. That's both the layout and setting up the Figma bridge for export. And then a couple of weeks added on to that on the Design Studio side, creating all the connections and interactions. So around a month, that's just one person working on it. Obviously, a larger team, that process could be much shorter.
Fair. All right. Oh, and actually there's another one. Is there Qt Bridge for Affinity Designer?
Not right now. That could be something that is addressed in the future. Currently, our bridges are Photoshop, Sketch, Figma, like I was showing, and the latest release one is Adobe XD.
Okay, wonderful. And then this is the last question that I have here. But of course, if there are any other questions, please put them in the Q&A. But why are we seeing, and I think this might be for you, Pat, why are we seeing functional safety requirements for HMIs now, and how is this addressed in the past?
Yeah, that's a great question. In the past, not everything had a UI, or UIs were simple. They were light bulbs saying, yeah, we're green, we're go, or red, we're stop. And as we're seeing the proliferation of displays, high fidelity graphical displays on devices everywhere, a lot of those signals, those indicators that used to go to light bulbs, now they're drawn on a screen. And maybe not just a light bulb, maybe it's a text message that gives a more descriptive, like how you should respond to this condition. So we're seeing more information put on displays. And so just as I think the way you solder wires to light bulbs or whatever, that probably had to be done in a safe way. Now drawing to the screen, drawing to a display has to be done in a safe way. So it's really, as screens get bigger and encompass a broader range of information, and as screens get deployed everywhere, we're seeing more and more functional safety related content on those displays, and we need to have a way to address that.
Very fair. All right, and the last question is about slide distribution. So as a heads up for everyone who attended, as well as everyone who registered, we will be distributing a recording of this webinar following the fact. So be on the lookout for that, and you will be able to obviously access or review the slides as part of that recording. So more to come there, but that is the last question I have. So unless there are any others, I think we're good to wrap it up. Give it a minute, but I don't see any more questions coming in through the Q&A. So with that, thank you so much. Thank you, Shawn, Pat, and Elton for leading this webinar today. It's been incredibly educational. And like I said, please thank you everyone for attending, and be on the lookout for the recording following this webinar.
Great, thank you.
Thank you. Have a nice day, everyone.